All right, welcome to the cryptography working group, March 6th. The schema that the algorithm family schema that we reviewed last time is it's still in its same state. I have not had a chance to work on it, but I'm going to try to get that checked in, likely this weekend sometime. And that way we'll have something to kind of discuss in GitHub issues or asynchronously if we want. I still need to make the changes that we discussed last time, Nicholas, where the algorithm names themselves are kind of um, reusable objects, all the properties, because they're all kind of the same right now. So I need to properly modularize what I have so far, and then I will get that checked in, and we can kind of discuss it. We can continue on with algorithm names, but there's also the other elephant in the room with the curve names as well. And that's going to be a little bit of research that we need to start, although we do have a really good starting point for that. So, Nicholas, do you have any updates?
So not really updates, but I just can confirm my to-do list still contains the fixing the PR. I will do that hopefully until next week. So yes, this one, and help Basil hopefully with the algorithm name so that we can work there together.
Okay.
Yeah, I think there's also some internal resource that we can leverage for that next to Basil and myself to speed that a little bit up, because there's also some need from product side to solve this algorithm name standardization. So yeah.
All right. So where does the group want to focus on today then?
I think what Basil mentioned, that we can quickly look at, and because I just had a read on what you shared, Basil, the last week. I hope I understood it correctly, but if you could maybe share a little bit what your thought was with the algorithm, how you grouped that, and basically also maybe where the methodology is, how you want to go forward from there, because maybe then we can find a way to parallelize the efforts. Yeah. So basically that I can help you too and know where to.
Makes sense. It's a lot of reading, basically. It's a lot of reading standard documents and then following the references to other standard documents, and then getting the information from there. So that's basically the work behind that. Yeah, maybe I can share just the initial list that I have. Or, I mean, let's just start. I mean, the idea was kind of to have a bit, let's say, look at use cases of where cryptography is used, right? The first one that I'm looking at now is TLS. I mean, TLS 1.3. There is an RFC for TLS 1.3 that you can go. Basically, the task there is to go through that, identify all the cryptographic algorithms that are defined there. It's kind of this negotiated protocol where you can use many different, signature algorithms, curves, ciphers, and so on. And then for the schema, then there are some information there to extract. I mean, first the family name, algorithm family names. And then because algorithm families, they most of the time they map to a certain standard, one or many. Then you can look up these standards like a FIPS standard from NIST or another RFC and go through them. And there you will basically have the algorithm variants and then try to identify a certain pattern, right? Or something like a regex. I mean, I did some kind of dummy regexes for some examples. I mean, I think they are not valid yet, but just to see what makes sense there. And then, yeah, I mean, that's it. I think that would be the general approach, right? So there is TLS 1.3, there is another one for 1.2, 1.1, 1.0, and then some other SSL version 3. And then we can look at other protocols like, IPsec, PKCS11, which is used in any communication with some crypto token or a hardware token, hardware module. But then also doing the same thing, kind of let's say more bottom up, right? I think that's what you already did for the CBOM kit, right? Looking at Bouncy Castle, what is there, what algorithms are implemented there, and some other popular crypto libraries. So, to have let's say, I mean, CBOM has the use case is probably in many cases something related with TLS, right? Or in many cases. So we have, for example, all of that covered somehow in algorithm names for TLS, right? And for other popular protocols and use cases. So I can, maybe you can share my list. I can also share it then over Google Docs later or over GitHub. Where can I share here? Here. That's the list. I mean, just looking at the protocol, that's TLS 1.3, right, from RFC 8446. So that's just the context. And then, right, so there is a section there about signature algorithms. And I went through all of these signature algorithms. And there is a link from TLS 1.3 to some standards, RFC 8017, IEEE 1363, and there RSA is defined. Now, RSA has RSA is not just one algorithm, right? So there are different algorithm families that identify what it actually does. So RSA is a signature scheme, right? RSA, SSA. I think the SSA stands for signature scheme with appendix. Because there is a mask function involved there. PKCS1. So that's one of the families. And then I try to define kind of the variant with a pattern, right? So that the name of the algorithm would be RSA PKCS1 1.5. And then you have the digest algorithm or the hash algorithm, which is one of those, right? I mean, they could be listed explicitly or maybe just as a maybe some kind of reference. And the key length, right? So that would be a possible pattern for that. Then there is RSA, SSA, PSS. So that's also a signature scheme, right? But with works a bit differently. Probabilistic signature scheme. And then again, we have the standards defined here and the variant with a pattern. In this case, we need a digest algorithm. A salt length is also part of the algorithm, and the key length. And I have some examples here what the values can be. And then again, RSA. So next, RSA is also an encryption scheme, or can be used as an encryption scheme, which is also defined here. Here, the primitive is not signature, but PKE.
Mm-hmm.
And then there's another encryption scheme. It's RSA OAEP, which again comes with different variants that can be represented with this pattern. Then there is also in TLS defined, there is at DSA can be used, which is defined in another RFC. And here there are variants. It's a bit simpler here than RSA because there is just at 255.9 and at 448, and then there is either without any appendix or PH, which is a pre-hash version of it, and CTX, which is kind of where you can attach I think the idea is if you sign a message, you can add as an additional parameter a context string which can be useful for some applications. And the next one, of course, ECDSA, elliptic curve digital signature scheme, which is defined in a FIPS standard, but also in X962. The variance here is ECDSA and then curve, right? I mean, I didn't look at. I mean, that's another separate task, right? To write down all the curves, and then a hash function.
And that variant is basically how it is defined in the standard, like with the name, because I know, for example, for Java, it's just the hash in front and then with ECDSA, but they don't explicitly name the curve there. So it's just how they name it in the JCA. That's why I wonder if this is basically if that's their schema to define that, and don't name the curve and just have it in when you program it you have to specify it, but not in the algorithm name. Is that this is basically the standard in the standard height, or
I mean, I think it's. I mean, I tried to follow the naming if there is any naming in the standard, right? And kind of more or less the pattern. And yes, I mean, ECDSA, you always need a curve with it, right? Not sure how it is in this case, if there is a default curve, right, somehow behind that, or if you need to specify it with another API. What curve is used.
Basically do.
But yes, it's always a curve that is needed. And I mean, maybe we can also, I mean, if we don't know that, right? If the scanner doesn't know that, I think we could also add an option here to leave that empty, right? This specification.
I mean, that's currently another discussion we do have internally, but maybe also relevant here. How to report basically unknowns. It's more from a scanning perspective. Leaving it blank could just mean there's nothing in some cases, depending on the naming. But maybe that's then misinterpreted as it's a different kind of algorithm, then there is a value that we didn't found. So this task is still also from a scanning perspective on our plate, but it also basically a little bit refers to the naming too, because I think when we have a naming based on parameters and from the scanning perspective, we don't have all the parameters. What do we do then? Do we leave it blank? Do we put an unknown token in there saying, okay, this explicitly we don't know, but it should be there? I don't know if we should discuss it in the same topic as the standardized naming, especially speaking about the variants. But it's definitely an unsolved question on our side how to tackle that.
Yeah.
Yeah,
Yeah.
that's going to be unsolved. And then my question, first of all, Basil, very good work. That this has a lot of the stuff necessary to start populating the schema. Or the thing that I'm working on, which is fantastic. My question also from a scanner perspective is that will the variant pattern that we have here, hash algorithm, mass gen algorithm, key length, etc. Will the tools know what these things are? Or do we have to define those as well?
Yeah, I mean, was also with the reason why I just left them as that, right? While I mean here with I mean compared to AES here,
Yep.
I tried to just take all of the modes that are specified in this NIST special publication, right, and list them explicitly. So I think these are kind of the two options, right? To leave it open or to list them explicitly, right? Because I think what we will have here, I mean, like with hash algorithm, they are also defined separately here under, we have this primitive hash, right? And then here we have the definition of all the SHA-2s, SHA-1. Now TLS 1.3, I think, doesn't have SHA-3, right? But SHA-3 will also be there eventually. So that information will also be available in the schema, right?
Okay.
I'm not sure what's the better approach. Yeah.
I mean, I like what you've done here. My other question, I guess, is kind of piggybacking on what Nicholas asked, where the variant, the pattern that exists in the wild might be different from what the standard actually says. So would it be good to capture maybe the authoritative or canonical pattern versus other patterns that also describe this thing? Is that, or is that just overkill?
So you mean also capturing the kind of some alternative way to represent the same thing?
Yeah. I mean, I'm leaning toward just capturing the authoritative one. The Scan OSS project has got basically just a bunch of patterns. So that type of data already exist, but like Java or OpenSSL, if they have patterns that do not conform, is it worth documenting those or not? Right. The reason why I ask is that right now my variance property in the schema is an array. I can very easily turn that into a string. So we just have one, right? And here's the pattern. Or I can keep it as an array and we could theoretically have multiples. But if we have multiples, what's the use case for having multiples?
Yeah. And I'm not. Yeah. I think I would also tend to just have one possibility, right? And then it's just because the same thing is described in so many different ways, right? With some, underscore or just a dash or sometimes here for SHA, there's the SHA 512.224, right? Which is kind of you have SHA 512, but then you truncate the output to 224 bits. So sometimes I read that as 512 here slash 224, and sometimes I read it as 512-224, right? So, and maybe some others have an underscore, right? So it's thought maybe it's better to just have one, right? And then it's kind of a task of the scanner, right? If to do that mapping, right? I mean, the scanner will know how Java looks and then is able to map that to the schema. I don't know, maybe it would also be more difficult for analysis if we have different patterns, and then the task would be to kind of find out these two are actually the same, meaning the same thing.
Right.
Yeah.
Okay.
I would also agree with that, I guess. If it's also the right approach to have one variant described that we can use.
Yeah, and right. I mean, that's just the beginning of the list, right? But it already captures quite some, yeah, frequent algorithms. I mean, in TLS, still remaining is the key exchange algorithms. There is something like Cha as well, and then going through the other versions of TLS. Then I also quickly talked to Mike on our side, and he has already did some similar exercise coming up with algorithm names. Maybe we can also again catch up with him and think with the list he has. And then Nicholas can maybe also talk how we can split some of that work, if you like.
No, this is great. This is fantastic. Do we want to is this checked in anywhere, or how do we envision that we collaborate on this authoritative list, essentially?
Yeah, no, it's not checked in yet, but yes, maybe a Google Doc or a GitHub, maybe a I don't know, a list there.
Does the other collaborators know? I mean, I'm not going to assume that they are familiar with GitHub, but are they?
I mean, with just us, so I guess yes.
Oh, okay. I thought there was somebody else involved too. All right. This is what, a text file or markdown or something? This is, yeah. I'd actually prefer keeping it in like a text form. That way there's a less possibility to introduce like unwanted characters, like from a document format. So just keeping it like this, I think, would be fine. And if we want to check, if you want to check this in somewhere, let me know where it is.
Yeah, I will do so and share a link.
Okay.
Yeah.
All right.
Maybe a question regarding the schema, since I hope we do good enough work that we don't do any mistakes, but in case we do, how would we ensure backwards compatibility with the algorithm list? Is there like with that schema?
Yeah,
I was
that's a
just
good
wondering.
point. Well, I don't think the schema will really change. However, what we could theoretically do, so like if you look at like the SPDX license list, they actually have a property called deprecated. And for example, if they made a mistake, right, they can deprecate the use of that identifier and they can put a new one in there, right? Now, they
Oh,
don't
okay.
actually, I don't believe they actually have a way to say, well, this is the new one, right? I'd have to go back and look.
Mhm.
But theoretically, that's something that we could do, right? So like if we do make a mistake on the data side, we can deprecate something and then mark what supersedes it.
Okay, that sounds good. Yeah, I was just
Okay.
wondering because yeah.
Yeah, no, that's a good point.
Just don't make any mistakes.
Yes, pressure's on.
Yeah, I'm right on that. Okay. All right. So I just made a note to myself to kind of add those as well. Like I said, I'm going to try to actually, this is, yeah, well, it's in better shape than I thought it was, but I'm going to get this checked in over the next couple of days, maybe by Saturday if I'm lucky. And I will add the change that we made to just a single variant, and then I'll add the deprecation and superseded capabilities, and then of course all the other optimizations that I need to do to make this a decent schema. Okay. That's great. I like the approach too, because you're looking at the application of cryptography from popular protocols and whatnot, as opposed to the opposite way that the other repo was doing it, which was like more of a bottom-up approach.
Yeah,
So
and then I think once the most common ones are covered, right, then we can still see what are some more industry-specific ones that are useful to have, right?
yeah, absolutely. Okay, good. Sounds like we're wrapping up that topic for today anyway. I think there's some work that needs to happen asynchronously before we meet next. Is there any other topic the group wants to bring forward today?
I think when we are working on these algorithms, oh, sorry, please go ahead, Nicholas.
Oh no, go ahead. I just want to say, not for myself.
I
I'm
think,
happy if I have a little bit more time, but
oh, okay. Sorry, I have cold, so, and then it's evening time, so that's why I keep my camera off. Or you'll see my kids roaming around. Um, so, what I was thinking is that I think we can actually publish some kind of content on the internet once the whole algorithms are ready, or the way we are progressing, because it's important for people to know that this is the work that has been done. Like, I've seen that a lot of iterations are being happening on the open source side, and with this project also there are some really great happenings which are happening, and people get to know that these are the changes which we are amending or which the team is doing it. I think it'll be more interest for them to get started and contributing more around it.
Yeah. You're talking about specifically promotion and kind of a call to action to contribute?
Yes.
Yeah, for sure. Yeah. I think there's some stuff that we can do within OWASP, Vanana. If maybe
Yes.
Nicholas and Basel can go back to their employer and maybe get others involved, reach out to other industry partners.
Mm-hmm.
I think that would also be really good. There's a lot of changes obviously going on with the US government, so I don't know if people still are around. But I can try reaching out to some folks at CISA. I don't know a lot of folks at NIST because I think they would be interested in this as well. But it might be good to kind of inform them about this work because it ultimately is going to important and tie back to some of the NIST standards that are currently being drafted.
Yeah.
Okay. Anything else for today, or should we give everyone 25 minutes back?
I'm fine with the 25 minutes.
I agree. All right. I have my homework. So great meeting today. Great job, Nick, Basil. Appreciate the work on that. So that's amazing. And I'll let you know when that schema is checked in. All right. Cheers.
All right.
Have a
Thank
good
you.
have a
Thank
good
you
one.
very much.
Take care.
You
Bye.
too. Bye bye.